The life cycle of a star can be broadly categorized into several stages based on its mass. The stages and duration of each stage can vary depending on the mass of the star, but here is a general overview of the life cycle of a star. Stellar nebula. Stars are born from massive clouds of gas and dust called nebulae. Gravitational forces and external triggers, such as a supernova explosion, can cause the nebula to collapse under its own gravity. As the cloud contracts, it begins to spin and flatten into a rotating disk. Protostar. The collapsing cloud forms a dense core known as a protostar. At this stage, the protostar is not yet undergoing nuclear fusion but continues to contract and accumulate mass from the surrounding material. Main sequence. When the core of the protostar reaches a temperature of about 15 million degrees Celsius, nuclear fusion of hydrogen begins, and the star enters the main sequence phase. It is in this stage that the star spends most of its life. The energy produced by nuclear fusion balances the gravitational forces pulling the star inward, resulting in a stable phase that can last for billions of years. Red giant or supergiant. As the hydrogen fuel in the core gets depleted, the star's core contracts and heats up, causing the outer layers to expand. This expansion turns the star into a red giant or, in the case of more massive stars, a red supergiant. During this phase, the star becomes much larger and cooler than it was in the main sequence. Planetary nebula or supernova. In the case of low to medium mass stars, the outer layers are expelled, creating a planetary nebula. The core that remains, called a white dwarf, gradually cools and fades over time. For more massive stars, they undergo a supernova explosion, where the core collapses under gravity and rebounds explosively. This explosion releases an immense amount of energy, and the remnants can form a neutron star or a black hole. Neutron star or black hole. In the case of a supernova, the remnants can form a neutron star if the core's mass is between about 1.4 and 3 times that of the Sun. Neutron stars are incredibly dense and composed primarily of neutrons. If the core's mass is greater than about 3 times the Sun's mass, it can collapse further, forming a black hole. Black holes have such strong gravitational forces that nothing, not even light, can escape from them. It's important to note that the life cycle of a star can vary depending on its mass. Higher mass stars go through their life cycle more rapidly and end with more energetic events, while lower mass stars have longer lifespans and fade away more peacefully.